class, this is lesson 6.3, using similar triangles. Our goal here is we're going to use proportions to identify similar polygons. So last chapter we talked about things being congruent. That means all the angles, all the sides were equal to each other. Today we're going to talk about and start working with similar polygons. So two polygons are similar if, first of all, corresponding angles are congruent. Okay, so our angles are the same. And then corresponding side lengths are similar. So the thing that makes similar different from congruent is with congruent polygons, all the angles, all the sides are the same. With similar polygons, all the angles are the same, but your sides are related to each other. They're not exactly the same. So looking here, we want to fill in our corresponding angles, and you can see A and D would correspond. Angle B and angle E would correspond, and angle C and angle F would correspond. Corresponding sides, side AB and side DE, side BC and side EF, and then segment AC and segment DF. Now notice I didn't put my markings on there because they're not all equal. The way we write similar is like this. This would say segment AB is similar to segment DE. This is segment BC is similar to segment EF. And this is segment AC is similar to segment DF. We use that kind of similar, that little wavy sign here. So we're going to write triangle ABC as similar to triangle DEF just like this. Triangle ABC is similar to, here's your similar sign. Okay, it's like just the piece that we put over the equal sign for congruent. Okay. So example 1, triangle ABC is similar to triangle DEF. So if we list all the pair of congruent angles, we know angle A and angle D are congruent, angle B and angle E are congruent, and angle C and angle F are congruent. And I put my congruent markings down there because our angles are the same. Then check that the ratios of corresponding side lengths are equal. This is how we know for sure that our triangles are indeed congruent. If our angles are the same and then our ratios are equal to each other. So segment AB and segment DE, remember AB with no line above it means the distance, so that's 10 over the distance from D to E is 15. If you reduce that, divide the top and bottom both by 5, you get 2/3. The distance from B to C is 8 over the distance from E to F is 12. Divide them both by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. The distance from A to C is 12. The distance from D to F is 18. If we divide those both by 6, you get 2/3. So notice we got 2/3 for all three of the ratios when we simplified. So since the ratios were the same, we know they are indeed congruent or similar triangles. So C, write the ratios of corresponding side lengths in a statement of proportionality. So we'd say segment AB is similar to DE, BC is similar to EF, and AC is similar to DF because the ratio of each corresponding side length is equal to 2/3. So our scale factor here, this is just the ratio of any two corresponding lengths in two similar figures. So that's really what we just found. We just found 2/3 for the other problem we just did. 2/3 would actually be your scale factor here. So example 2, determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. So if they're similar, that means all the angles are the same, all the angles are congruent, and all the sides are proportional. So identify pairs of congruent angles. You can see the markings are already on here, so this is pretty easy. Angle A is congruent to angle J, angle B is congruent to angle K, angle C is congruent to angle L, and angle D is congruent to angle M. That's already on there. You should be able to see that. Step 2, show that the corresponding side lengths are proportional. So we need to do exactly what we just did in that last problem. So is AB similar to JK? So AB is 8. JK is 14. Well, they're both even. 8 divided by 2 is 4. 14 divided by 2 is 7. Segment BC is 8 over segment KL is 14. Again, that reduces to 4/7. Distance from C to D is 8 over the distance from L to M is 14. Again, that reduces to 4/7. The distance from D to A is 12, and the distance from M to J is 21. Those both have 3 as factors, so 12 divided by 3 is 4. 21 divided by 3 is 7. So they do all reduce to the same thing when I write that, and as we just said, that would be our scale factor. So our similarity statement would look like this: ABCD is similar to JKLM, and our scale factor we just found, it's 4/7. So example 3 here. In the diagram, triangle BCD is similar to triangle RST. Find the value of x. So knowing that they're similar, that means automatically all the angles are congruent to corresponding angles and the side lengths are proportional. So we're going to go back to what we did in the last chapter. We're going to write a proportion. So I know 5 and 10 down here, those are corresponding sides that I know both of. And here's my unknown, my x, and here's the corresponding side for that. So I'm just going to write a proportion. Remember, you could write multiple ones. There's different proportions that would all be the same here. But I'm going to write 5/10, my smaller triangle over my larger triangle, equals, I want to do my smaller over my larger again, so 13 over x. For both of them, I did the small side over the larger side. But I kept them with corresponding sides here. So if I simplify this, 5 times x equals 10 times 13. This is something we did in the last lesson. So 5x equals 130. Divide both sides by 5, and x equals 26. And I found x. It says find the value of x. That's all I had to do. There's my final answer. Hey, find the scale factor of MNPL to GHJF. And we want to find x. So first we need to find the scale factor. We don't need to go through all the sides. Let's just do one of them. Okay, and I'm going to pick probably the smaller ones. It says MNLP to GHJF. So I want to use this one first. So I'm going to use 12 right here. So I'm going to say 12 over my corresponding side length on GHJF is 15. So that reduces. 3 goes into both. 12 divided by 3 is 4. 15 divided by 3 is 5. So there is my scale factor, 4/5. So I know that all of those corresponding sides, if I made proportions, they'd all reduce to 4/5. So 4/5 to find x, I'm going to use that. So 4/5 equals, the 4 is from my smaller shape, and the 5 is from my larger shape. So this x, well, that's a side from my smaller shape, so it's going to go on the top, and 40 is the corresponding side from the larger shape, so that'll go on the bottom. So I set up my proportion. Now I just need to use the cross products property. 5 times x equals 4 times 40. So I have 5x equals 160. Divide both sides by 5, and x equals 32. So see how we can use our scale factor as well. There's other different proportions that I could write to solve and find x the same way. So theorem 6.1, perimeters of similar polygons. So if 2 polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So just like we can find a ratio, find a scale factor from the side lengths, the perimeter also, if we were to add all the side lengths for both of them and then make a proportion of our perimeters, it would equal that same scale factor. And I just want to show you that, so we put some numbers here. So I'm going to find the perimeter of KLMN and the perimeter of PQRS. Find the perimeter by adding them all up. So if I add them all up, I get 14 over 28. And as you know, that could be reduced. They're both even. 7 goes into both. That reduces to 1/2. So if you do a ratio of the perimeters, you get 1/2. Now, let's find the ratio of the side lengths. So KL is 4 over 8, which reduces to 1/2. LM over QR, well, that's 3 over 6, which is 1/2 as well. MN over RS, so that's the ratio of another side, that's 5/10. which is 1/2 also. NK over SP, well again, that's 2/4, which reduces to 1/2. So you notice the scale factor of all my sides, after you reduce that ratio, is 1/2, just like it was for the perimeter. So the proportions are the same for perimeter and side lengths. So I'm just going to fill this in. This stands for the perimeter, and here's my individual sides. So we can use that idea with problems like this next one. It says a larger cement court is being poured for a basketball hoop in place of a smaller one. The court will be 25 feet wide and 20 feet wide and 25 feet long. The old court was similar in shape, but only 16 feet wide. So first, find the scale factor of the new court to the old court. Okay. So if I'm just going to quick sketch a picture here. So my new court, I want this to be 20, and I want 25 here. So this is 20 feet, that's my width, and 25 feet, that's going to be my length. Okay. My old court, it's going to be smaller, so I'm going to draw a little smaller picture here. It says the old court was similar in shape, but only 16 feet wide. So 16 feet, and that's my width. Okay. And I'm going to find this one. So let's write a scale factor. I can see that 16 corresponds with 20. So 16 out of 20, well 4 goes into both of them. 16 divided by 4 is 4. 20 divided by 4 is 5. So my scale factor is 4/5. Now let me just check something here though. I want my new court to my old court. Well 16, isn't that my old court? I said my old to my new. I want it the opposite way. So instead of 4/5, if I want my new to my old, it's going to be 5/4. So 5/4 is actually my scale factor from the new court to the old court. Sometimes you got to watch the wordings. If you see that word to in the middle, the first thing goes on the top of your fraction, the second goes on the bottom. So 5/4 is what I multiplied my old court by to get my new court lengths. So find the perimeters of the new court and the old court. Well, I can easily see this new court. This side's 20, this is 25. So 25, so for my new court, 25 plus 25 plus 20 plus 20, that's 50 plus 40, which is 90. So that's the perimeter of my new court. For my old court, well, I don't know that last side, that length of the side, but I can use what I did on the last problem, or the last definition, the last idea here, and I can say that if I make a proportion, 90 is my perimeter of my new court, X is my perimeter of my old court, that's got to equal my scale factor, 5/4. So I just set up a problem here. I'm going to do the cross products property. 5x equals 90 times 4. So 5x equals 360. Divide them both by 5. And x equals 72. And that's the perimeter of my old court. So 72 feet is the perimeter of the old court. Example 6 says triangle WXY is similar to triangle PQR. So that means all our sides are proportional. Find the perimeter of triangle WXY. Oh, look it, they give me all three of the side lengths for this one. So I can easily add those up. If I add those ones up there, let's see here, 72 plus 63 plus 81, 6, and let's see here, that's 216. Okay, so there's my perimeter of my larger triangle. Okay, if I want to find the perimeter of this smaller triangle, it's my unknown, so I'm going to make that x. Well, can I write a proportion using these two sides? I can say 40 out of 72 equals, I don't know the perimeter of my smaller triangle, x out of my perimeter of my larger one is 216. So I use the perimeter to write a proportion here. Let's use the cross products property again here. So 72 times x equals 40 times 216. So I've got 8,640 equals 72x. Divide both sides by 72. And x equals 120. So the perimeter of my smaller triangle is 120. Here in the diagram, triangle FGH, so triangle FGH, that's my larger triangle here. I just outlined it in blue so we can see it a little better, is similar to triangle JGH, triangle JGK. Okay, so it's this triangle. So we've got the larger blue triangle and the smaller green triangle. It says find the length of the altitude of GL. So my altitude runs from the bottom to the top right here. I'll do that in blue again. So this is my altitude. It comes straight up from the bottom at a right angle. So this is the side, this whole entire thing, from G to L, segment GL, I want to find that length right there. So I'm going to set up a proportion. Well, the base of this triangle is 16, and the base of this green triangle is 10. The altitude of this green triangle is 14, and we don't know this entire altitude. That's my unknown. So I'm going to say 10 over 16, that's the base of one, base of the smaller over the base of the larger triangle, equals 14, that's the altitude of my smaller triangle, over x, the altitude of my larger triangle. Use cross products property again. 10x equals 16 times 14. Okay? So 16 times 14 is 224 equals 10x. Divide both sides by 10. And we have x equals 22.4. And that is the height of my altitude. Next one, last one. Find the length of segment QS. So I'm trying to find the length of this segment right here. That's my unknown, so I'm going to put x in here. Well, I know that this is 24 as well, so this total side is 48. These both have two markings, so this whole bottom is 32. 16 plus 16 is 32. So let's say the base, or the bottom side of my smaller triangle over the bottom side of my larger equals my unknown over 39. So I use my corresponding parts to write a proportion here. Okay? So again, we can cross multiply. 32 times 39 equals 48 times x. So 32 times 39 is 1,248 equals 48x. Divide both sides by 48. And x equals 26. And that is all for this lesson. That is the last part of the notes. Remember, star any problems that you were unsure of, put stars next to them so that tomorrow in class we can go through them and make sure you understood all of it. Have a great night.